Hey everybody, in this video we are on section 4, exponential and logarithmic equations in the unit of exponential and logarithmic functions. And in this video we're looking at example 2, and we're solving exponential equations in a situation where we cannot use mental math and one-to-one property, where we have to use log. And commonly you'll see people use ln or natural log and take the natural log of both sides. I'm going to show you how I would initially teach it to a standard algebra 2 class in the beginning, but then I will quickly turn it over to ln and focus on that moving forward. So just a quick little chat, but if I had an example like example 2 below, where I have 4 to the x power equals 15, I can't make them both 4 to a power, 2 to a power, anything like that. It's not natural in that way. No pun intended with the natural. So what am I going to do instead? Well, what I want to do is I'm going to do the exact inverse of 4 to a power, which is log base 4. Like I said, this is how I would do it with a general algebra 2 class. Now what happens if I take the log base 4 of both sides? Well, log base 4 and 4 to a power are exactly inverses of each other. When you compose a function with its inverse, you are left with only the input right there, in this case x. So x equals log base 4 of 15, and that is an exact answer, and we solve for x and we're done. However, if I wanted the decimal and I don't have a log base 4 button on my calculator, I can use change of base formula, and we saw that in an earlier video at the end of section 3. And I would lean into using natural log, so I would end up with the natural log of 15 over the natural log of 4, and that's what I would type in the calculator. You'd want to make sure that you close all parentheses and type it correctly, right? You should get something a little bit smaller than 2 as your answer, because the question was 4 to what power is 15, and since 4 to the 2 is 16, you know your answer should be a little less than 2, so you want to make sure your answer makes sense, right? Now, that's the answer that we would get at the end of the day. But in a class like a higher level algebra 2, or a stronger algebra 2 class, or maybe a pre-calculus class, I'm just going to dive right in to using natural log. So in that situation, I would immediately take the natural log of 4 to the x, and I would also take the natural log of 15. When I have log of something to a power, from power property, we know we could bring that power out front, and we're left with the natural log of 4, which is just a numerical value like square root of 5, right? It's just something we don't know the answer of off the top of our head. That x is being multiplied by the ln of 4, so what I'm going to do is divide by ln, or natural log of 4, to get the x alone, right? Here it's gone, and I am left with x equals natural log of 15 over the natural log of 4. That is an exact answer. Again, if you punch this in the calculator, you should get something a little bit less than 2. I'm not going to open the calculator right now, but do that in your calculator and see, do you get 1.9-ish? If you do, you're probably doing it correctly. This over here, for example, 10 to the 5th. What do I know about 10 to the 5th? I know that 10 to the 5th is a 1 with 5, oops, where am I putting that comma? Hello. A 1 with 5 zeros, right? So I know 5 as x would get me that, so I know the answer to this should be a little bit bigger than 5. So that's also how you can check your answer later when we're all done. So now I'm going to do this question just like how we just did the most recent one. I'm going to take the natural log of 10 to the x. Could I use common log because it's going to cross right out? You can, but it really doesn't matter. And if you plan on taking calculus, you probably should just get acquainted with natural log, because you'll use that quite often. I don't really know why I put 120,000 in parentheses. It doesn't matter one way or the other. X is going to come out in front. So you have x ln 10 equals ln, or natural log, of 120,000. 1, 2, yeah, maybe I put the parentheses so I can see what I'm doing, Divide both sides by the natural log of 10. And there you have it. That's gone. X is alone. And my final answer is natural log of 120,000 over the natural log of 10. Again, punch that in your calculator and see if you get the right answer. Let's look at the next example. Next we have natural log of 5 to the x power equals the natural log of 134. Could you approximate that? I know 5 to the third is 125, so you know it's a little bit bigger than 3. Good habit to have. Now, in this problem, the x, I'm going to try to write less, is going to come out front. So it's gone from there. It's the same size as the natural log. It's the same size as the 5. It's no longer an itty bitty exponent, right? Divide both sides by the natural log of 5. Natural log of 5 is gonzeroni, gone. So what do I get? I get x is equal to this bad boy right over here. That's your exact answer. Punch that in your calculator and see if you get a little bit bigger than 3 for your answer, and then round up when appropriate and to whatever decimal place is being indicated by the question. Next up, 10 to the third is equal to 1,000. 10 to the 4 is equal to 10,000. So you know it's going to be a little bit less than 4, the answer to this question, right? So let's go ahead and do it. So I'm going to take again natural log of 10 to the x, but then that x, there it goes, out front, lovely, equals the natural log of 8,000. And divide both sides by the natural log of 10. Punch that guy in your calculator and see if you are indeed getting a little bit less than 4 as your final answer. ln of, or natural log of, 8,000 over the ln, or natural log of 10. But if I leave it like this, which I honestly prefer, you're actually being more precise, as that is the most exact answer. I would only round it with a decimal if the question indicates that I should do so. If it says to find the approximate answer, that means you're using a calculator. If it says to find the exact, you should be able to do what I just did, and every answer I boxed in is the exact answer. Okay? So if you loved it, that helps you a lot, then thumbs up. No, not so much. Thumbs down. Questions, comments, concerns, requests, feedback in the comment section, please. And check the playlist or description box for more videos on this topic. And that's it for now. See ya in the next one. Adios.